friends, welcome back to chemistry. This is our fifth and final week of chemistry lessons, and I'm very excited about all that we have covered in these last several weeks together, and excited to finish off this unit of chemistry with you. Today we're going to talk about different states of matter. Oh yeah, and I wanted to show you, I just got my new t-shirt in the mail, and just in time to share this last video with you. And it says, never trust an atom because they make up everything. So anyways, thought that was kind of fun. All right. A physical property or characteristic of molecules is that they are always in motion. How they move depends on the amount of energy they have and the state that they are in. The more energy a molecule has, the more it moves around, just like you and I. The way a molecule moves around is an important difference between solids, liquids, and gases. So first, we're going to talk about the solids. Any matter that has a definite shape is a solid. A definite shape does not change. For example, a piece of jewelry like my earrings, or a chair. If you remember in our very first set of videos, we talked about matter, and I showed a number of different kinds of chairs, and these were all examples of matter and the different kinds of matter, but all those chairs were examples of solids, and they have a definite shape, and that shape doesn't change. So solids also have a definite volume, and that is the space that something occupies. So the space that that chair occupies. A solid is characterized by its definite shape and its definite volume. These are things that don't change in a solid. So yeah, here we have some examples of solids. We have ice, which is water in its solid form. We have a metal fork, and we have several pieces of wood, which can be used to make things like chairs or houses or other kinds of furniture. So the properties of solids cannot easily be compressed. They're not easily controlled. Solids have definite volumes and definite shapes, and solids usually have a high density. So that is, density would be another physical property of a solid. It is important to remember, though, that even though a solid will have all of these properties, the molecules are still moving, even if just a little bit. And this gives them their solid and definite shape, okay? So even if you look at something like my table or the TV, you have to imagine that on the molecular or atomic level, things are still actually always moving. So here we have a picture of a solid, and it just shows again that these individual atoms are in motion. Now the next form of matter, the next state that we're going to look at is liquid. And in liquids, the molecules are moving faster and moving more than they would be in solids because they have more energy than they do in solid form. So one of the physical properties of liquids is that they do not have a definite shape. Liquids can take on different shape depending on the shape of the container that they're in. So if you see in this picture, we have all these different liquids that have taken on the shape of whatever container that they have been poured into. So liquids do have a definite volume, which can be measured in any of these containers, but they do not have definite shape. So if you poured a liquid out, it would make a mess. We all know this. We've probably all poured things out or dumped something over, and what we have is a mess on our hands. So here we have the definition of a liquid. It has definite volume but not definite shape. It takes on the shape of whatever container that you pour the liquid into. Liquids are often called fluid substances substances that flow. And liquids can be poured. So what we have is we have the next type of or form of matter, and that would be the gas. So we have solids, liquids, and gases. And in this slide, we see that solids, the atoms are closely packed together, and they would just be moving a little bit. Then we have the liquid that will take on the form of whatever container that they're put into, but they don't have a definite shape unless they're put into a container. But they do have a definite volume. And in that, whatever volume or container they're in, those molecules are moving even more than they are in the solid. In the gas, we know that the molecules are moving even faster. They have even more energy. And so molecules in solid move slowly, molecules in liquid move faster, and molecules in gases move the fastest. So molecules in gas form have the most amount of energy. Gases do not have definite shape or volume, and they tend to spread out more. So here we have, again, the picture of solids, liquids, and gases. So the gases put into a container will want to escape the container unless there's a cap or somehow they're enclosed in that container. And gases are the molecules are very far apart and will occupy any space available, and they will move randomly at a high speed. And there is a weak force of attraction between the atoms or the molecules in a gas. Here we have a balloon that is filled with helium. And this is one way that a gas can be enclosed into something. And so the gas will remain in a container if it's tightly enclosed, like this balloon. We can fill a balloon with air. We can, fill it up with our breath and close it up. Now, helium is lighter than air, and so it wants to rise in the air. And you know that a balloon, if you just blow into a balloon and tie it up and let it go, it's going to drop. That's because it's just filled with air and CO2. We can have oxygen, nitrogen, and carbon dioxide or helium enclosed in a balloon like this. Other examples of gases at room temperature would be hydrogen and all the noble gases. Gases obey certain laws, which means they behave a certain way, and they behave this way all the time. These laws are concerning the temperature, the volume, and the pressure of the gas. Pressure is a word that describes the force applied to something, and it can be measured. So here we have the definition of pressure. Pressure is the action of one force against another over a surface. The pressure, or P, of a force, F, distributed over an area is defined as P, pressure, is equal to force divided by the area. We will only be concerned with two gas laws at this time. In 1662, this physicist, Robert Boyle, discovered what was called Boyle's law. And it states, Boyle's law states that for a fixed amount of an ideal gas kept at a fixed pressure, the volume and pressure are inversely proportional. So what that means is that under constant temperature, so if we keep the temperature constant, but we increase the pressure on something, then the volume of the gas can be forced to go down. So we can force the volume down by increasing pressure if we keep temperature constant. Pressure, the force of pressure, is measured in pounds per square inch, or PSI. You may have heard that before. In 1787, scientist Jacques Charles discovered another law, and it was called Charles' Law. And this one states that as temperature increases on a gas, the volume also increases. So they're directly proportionate, but only if pressure remains constant. So here we go. We have this slide, and it shows that this is a container with gas in the container, and it is being heated up, okay? And so the temperature is increasing. So you see here on the graph that the temperature is going up, and so the volume will also go up. So these scientific laws that have been discovered over time should always be testable with the same outcome. So you can always test these laws and should be able to predict that you will have the same outcome each time. And so here we have a definition of a scientific law. Scientific laws describe what nature does under certain conditions. If those conditions are present, then the law can be used to make predictions that should happen every single time. We know that phenomenon A always happens when conditions 1 and 2 are met. Scientific laws are well supported by evidence and have been tested repeatedly over time. Okay, and that brings us to the end of our first video for this week about the different states of matter. And I just want to go back to the sodium chloride experiment, show that the thing that I showed you a couple weeks ago. And last week I showed you that it had partially evaporated. And here I just wanted to show you that now the water has completely evaporated out of the beaker, and we are left with only the sodium, or the salt. So it shows that we can separate a solution or a mixture into its components. So there you have it. And if you have done the same experiment yourself, or this activity, and if you have pictures you want to send me, that would be great. I'll just take time right now to say that I've had some pictures sent to me the last couple weeks over some of these hands-on activities that have been done at home, and I've loved seeing these pictures. And so I thought, man, it would be so great to end off our chemistry unit with maybe a slideshow. And so I'd like to give more people an opportunity to send some pictures or short videos of some of these hands-on activities that you guys are doing at home so that we all could enjoy them together. And I'd like to put together a slideshow for everybody to see. We could probably post that on YouTube or something where the videos have been put. And so, yeah, I'd like to give you guys this week to maybe do some of these hands-on activities, send your pictures in. If you would have them to us by the end of Friday, that would be fantastic. And we'll try and get a slideshow together for next week that I could send to you over email.